before we start building our own HTTP server, I just want to mention that there are a lot of options in Haskell already with different levels of abstractions and batteries included. The web application interface is where it starts. It has kind of low-level mechanism for talking about requests and responses where we declare applications as a function from request to response. Another core library in Haskell is Warp, which is lightweight web server for these Y applications I just mentioned. It takes these applications or descriptions of requests to response and adds all the functionality on top of it. It adds network functionality, concurrent processing, taking requests, responding with responses, and so on. This is the core of it. All the other frameworks and libraries are built on top of it. The tiniest one called Twine or Twain, tiny one, has just the basics. On the next level, we have Scotty, Spock, and Snap frameworks. All the three are smallish to mid-size frameworks. If we step aside on the complexity abstraction batteries included, we get Servant. In a nutshell, we talk about the web API as a Haskell type. For example, the user's API in example declares the user route. I'd say that Servant is the most Haskell framework, meaning if you like it, you like it a lot. If you don't like it, you won't like it a lot. If we go to the higher levels, compared to all the things we talked about before, we get Used, which is a full package. You get everything you need to build type-safe web applications. It can integrate with databases, do all the login and everything else. But it's not 100% batteries included. The 100% batteries included framework is called HP, which is supposed to be Ruby on Rails, which is Haskell version of Ruby on Rails. Anyways, the actual reason is that I got invited to try CodeCrafters. They have courses and challenges on building software and stuff from scratch, and they have a Haskell track where one of the courses is to build an HTTP server. So I wanted to try, share it, and let's see how it goes. Seems pretty simple. Just get post request, serving files and stuff, and we're gonna do it in Haskell. Language proficiency, beginner. Let's pretend like I'm doing it because I'm not confident, but because it's a tutorial for beginners to see it from the beginner perspective, so other can see. So yeah, probably a few times a week, and I don't need any accountability. I can do it myself. So let's clone it and commit the first empty message to say, oh, I see. So they're running compilations and testing, and first error, you don't even need to install Haskell. Okay, it's pretty good. That's really easy. So yeah, they run stuff on push, and theoretically we don't have to run stuff locally, but I think it's gonna be easier to do it. And then the first task is to just uncomment the code and then to push. Okay. Of course. I just wonder if we can build it locally before we push. It's, yeah, 9 for 6. Okay, maybe we don't build it right now. Let's just uncomment. I think not just this, it's not useless. Yeah, I guess we just need to uncomment everything. Okay, let's just pass it and see. Okay, once again, as success. I'm just already 3 out of 10. It's pretty good. Okay, so now I think we need to start implementing stuff, and there's nothing to uncomment. So we need to read the data from the connection, respond with just bare okay. First one is the end of status line, the other one is responsive header section, and then we need to ignore everything. We don't get to parsing, and that's it. And if we want to pass it, we just need to commit and push our changes. Okay, I guess stuff begins. I think that's the real first one. And they have solutions. Yeah, I guess if you're really motivated, you can just see what other people are doing. I think it's fun. I think it's on HackerRank. It's one of the fun ones. You just submit stuff on HackerRank, and then you see your solutions, and then you see people golfing and doing one-liners. Anyways, as I said, there's network sockets that we can use. I don't think I have the luxury to use it before. TCP/IP protocol, example of server, which looks quite similar. Sending all messages, resolving, initialize and send. Yeah, sending. Yeah, it's different sending. It's a different package as I mentioned in the beginning. Let's just I don't think that's what we need. I think this, the byte string I use a dimension as well. Maybe that's the one that we need. Yeah, this one has sent to the socket. I guess this one, connection data. Let's import the network socket byte string and then send. I think the first one was a socket. We have a socket and then I guess we just send it. And it doesn't do anything. They have an instruction I see here. Okay, so I was thinking like running local is going to be some magic thing. I don't know, Dockers and stuff, but you just need to install stack and everything at once. Not a big deal. I think the only thing we need to do is just to install 946 GC. I didn't want to do it, but I just don't have enough space on my machine. I didn't want to install anything. I'll just install 964 for this. On 946, and while it's taking its sweet time. While we wait, I was just looking for the receive data, and there is a receive function that takes a socket, maximum number of bytes to receive, and then it gives us the data as a byte string. It has the maximum number says powers of 2, for example, 4096. I have no idea how much bytes we're gonna receive now in the future, so let's just use this magical number as it's here. Okay, so let's try it again. Now that I installed the correct version, I'm going to restart the server, which is just stack run. And if we run with just simple, we get a 200, okay, as we expect. And then if we try to run again, it's not going to work. Is it? I don't know. Does it take its time to reconnect? I don't know. Let's just try again. Yeah, it works. It's not just random 200, so it's 200 or 201, whatever we pass. The basic things is working. Now we just need to receive stuff. Well, let's just do it under the comment. So we have receive, and receive takes a socket, once again, an integer with max bytes, and we get the result of the byte string. Some data. I don't know what to do about it yet. Let's just give it a try. Okay, so they already imported the byte string for us that we're gonna use, and then we can just print it the same way, just to see what we received for the debugging purposes in the future. Probably is going to be useful. And this one is discarded as well because I think it returns the number of bytes it's read. I'm not sure I care now or in the future, so let's just silence the warning for now. And we can prefix it with underscore to tell the linters that we don't care and go back to 200. Let's just try to commit it and see. So the first test passed, and all tests passed. Okay, I don't know. I like it. It's pretty good. But yeah, I'm not gonna write a comment for them. Maybe later. Let's just continue. Okay, so the next stage is extract the path from the HTTP request. Let's just send the actual request. Looks normal. It looks normal. We have a start line. We have a couple of headers, and then separated it with not just a new line. And in this stage, we focus on extracting the path. If the path is a slash, like a root, we have a 200. I just wonder if lines, yeah, byte string has lines, but it should split on just the new line characters. Yeah, and it doesn't care about the. Well, could they write it down? Like I would assume that it works, but also at the same time, if we split on the new one, it might work for us. What else can we have? We can break string. If we break on what we are searching for, yeah, maybe that's the one that we need. Okay, let's just implement it. We can start with parse request function, which takes a byte string and returns HTTP request. Like for now, it's undefined. Byte string should be imported. Yeah, we just prefix it with BC. And HTTP request we need to implement. We create data HTTP request, which for now should just be a path. So let's start with our break substring function. We break on line breaks, and then we pass it our row string. The result is everything that came before the line break and everything that came after it, plus the line break itself, which is a bit annoying, but I think we can worry about it later, because we for now just care about the first line. So for now it's the first line is the whole status. So let's debug it for now. It's not a path. It's gonna be the whole line, but I'm not sure if it's gonna work. Like if it's everything is encoding is okay and everything is like that. So we don't even need this trace in here. The only intermediate thing we care about is what's first and rest. That's what I want to see, and the result we can just print after inside the AO. So inside the AO we can put string line and then get what we received, and inside the parse request where there's no IO, we just trace show it. We need a show, and then the by string we need to extract or show the. I think we just need to show it. So if we run everything and then send a simple HTTP request to the localhost for test HTML, we get 200, and in the logs we see that okay, the first line is get test, the status line is expected, and the rest has a line break in the beginning. Yeah, and then first line is extracted as expected. Yeah, now we can break this one, which is not a pass, but we can do it. I just hope we don't forget it later. Let's just write it down. Okay, let's parse it. So we want to extract the part that we care about for now. We take a byte string and we get the byte string we care about, the whole line, and then the words function the BC words function should break on all the white spaces. So in this case it's a space, but even, yeah, if it's a space it should break, and we should get the get, the path, and then the version. We can get the first one, but it's not very not the best, and also it's not as easy to extend later. So let's just better match on it, because I know it should be 3 of those: method, path, and version, and in case it's not, we should fail right away. There's no point of. Yeah, so if it's exactly 3, it's what we need, and if not, I think we just return maybe. We don't need to be fancy about exceptions and errors. If it works, it works. If it's not, it's not. So we just return just the path and just namings, and then nothing in other case, and we can ignore this. And then the name shadowing, yeah, it's a bit annoying. Let's just rename it to path 2 for easier. Okay, I guess this should work. Yeah, it's a path, not a header. And then we can do it on the first line here. We don't need to, but it's a maybe, yeah. So I guess the whole parse request also maybe. And here instead of, we just map it, and we can ignore the rest. So let's just print the path and see if it works or not. If we run again, and we call it, we should see that the path is test.html. Test.html, yeah. And if we pass nothing, is it going to be a root? Yeah, it's root in both cases. Cool. So next thing we have to do is to check for the path, and if it's a root, then we have a 404. I think we just better match on it, and we cannot because it's maybe HTTP request. It's not just the path. So we need to get the path. We can do it with just dot path, or we cannot because it's the extension is not enabled. So let's just add overloaded record dot to have a dot, but it still doesn't work because it's a maybe. So we need to extract the path out of the HTTP request. Yeah, maybe we just redo it. Let's do it just the whole pattern match, because for now we care about path, but maybe in the future we care about something else, so it makes sense to just extract or just pattern match and see what do we have inside the HTTP request. So we're gonna pattern match and get some status, because for now it's always gonna be the same version and everything else is gonna be the same. So we're gonna extract the response, and we're just gonna pass it as status and then concatenate everything we have before. I don't think we're gonna have any other version for now, and we're not gonna have headers or a body for now, so we just pass a status and it's good. We don't need this anymore. So the first one's gonna be 200, okay. The other one's gonna be not found, and pack all of it. It doesn't. It's not an AO. We don't need to bind. And the last case probably something like 400 internal server error. But if you didn't pass me a correct request, it's not my problem. It's not 500. It's more like 400, and it's your problem, I guess. So let's keep it, and we can just repack everything once. Let's give it a try. The previous get just works. And if we send something to somewhere else other than root, like test, it doesn't work. I guess we don't need the comment for now. And the tracing as well. Everything else looks okay. Let's just commit and push. So it compiled successfully, built successfully, and now it's trying to run the test, and it says that resource is busy, and then there was something red. So it failed to connect to the server. Timeout. Yeah, I don't think it's me problem, because it looks just a normal request. We can just give it a try. But everything else looks normal. Did they have some issues with resources on their side? Or is there something I missed? So maybe like this send somehow doesn't close, because we use this send at some number of bytes, and we are responsible for ensuring something that's sent, and this send all is just takes care of everything for us. So maybe let's just try this one and see, maybe it's gonna work. If we change send to send all, we don't get the number of bytes anymore. We can just run it. Try it with a given curl. 404 as expected. Let's just push it and see again. I don't know. Worst case, it just doesn't change anything. Yeah, once again, the resource is busy. Let's see if somebody on the website before us has figured it out. There's these two interesting lines here that one is sets reuse address to 1, I assume is true, which allows to reuse the same address without waiting for the operating system. It's useful, it says. And then the second one is also set close if needed. Another configuration. So both are related to closing and reusing stuff. So I'm adding this one. It worked. I'm not sure if something we missed before or now, but now it works, and I think it's okay. So let's just keep working at stuff. Now we have to respond with some content or with a body. We get a request to the get echo with some random string, and then we respond with 200. The content type is text plain, and response body has a few headers and a body. So now it's serious. I think because we're gonna extend all of this, it makes sense to move it to a separate module, call it HTTP request, move all the imports, move all the extensions, and then we can import the HTTP request here. Also, we need to re-export parse request, HTTP request. Okay, let's add a new handler for the new kind of path. Now, if the path starts with an echo, I think there should be something like starts with a prefix or suffix, and then we see if it has echo, then yeah, it would be nice to extract it already, because if we check as a boolean, then we have to do the prefix extractions again. I guess now we can get a prefix, and then if it matches, we pass the whole path to the handler, and then we just drop the echo and get the rest. And I think if we need to extend or do something else without it later, we can do it. So we can make some echo handler, because it's kind of getting too crowded in here. It makes sense to separate it and do it in a separate handler / function. The handler should take a byte string, which is a path, and return the HTTP response. So what's HTTP response? HTTP response for now is the version, right? It's just a byte string. The status or status code, which can be an integer, and then the status text, which is a byte string. we need to construct the HTTP response. I did it off screen, but it wasn't good anyways, so we can skip it and get to this version, which we can refactor and build on top of one. So we have functions that renders response. It takes a response, it returns a version, then a status text, and it combines them together with onwards function. Onwards function just adds a space between all of those, and at the end we add 2 new lines that, because we don't have headers and we don't have a body, that's it. And then when we add more stuff we can extend it, but at least now we have the way to render the basic HTTP response and make everything compile. But before we do that, we make a make response function, which takes the status code and the status text and returns HTTP response. We're not gonna mess with the version for now. We're just gonna pass the code and the text. And now we can use this make response with the previous, instead of the previous status code that we had, passing 404 and 200 and the dedicated status text. Okay, we just don't need to pack anymore because we already returned response and then we're gonna render it. The last thing to update here is 400 bed request, which is just response 400 bed request. We can rename pass to request pass to handle the warning. And response status actually response now. I'm not really a fan of having this maybes together with actual logic of matching requests. In this case, just paths. So I think we can break it down. We can extract the handler, which gonna take maybe HTTP request, and do the matching case. We can add lambda case expression to make it slightly nicer, which allows this syntax to just say /case. So we can simplify it and say that the whole accept connection thingy is just gonna take requests, put it to the handler, and then send it back. And all the logic moves to the handler. And we can refactor this to drop the code and text, because we simply passing stuff through. So the next thing to do is actually do the rest of it. We need a body. We need to add the body, which is also a byte string, or actually maybe byte string because body might be missing. And now we have to undo it because we pass in none as well. So we're in code status, and for now, let's keep it as nothing. In the echo handler, we need to extract the body. For now, it's just empty. And then the response is gonna be 200, okay, and the body. I think we can reuse make response and pass maybe byte string in there and make another one make response with no body. So we can reuse it in the places where we use the response with no body. We just say make response no body, pass 200, okay, 404 and other ones. And when we need to pass the response body, we're gonna use the make response with a body. Otherwise, it's a nothing. We need to strip the suffix from the echo path. We've kind of doing it twice. We check for the suffix twice, which is a no, and first we check it and the second time we strip it. So maybe we don't have to do it, maybe refactor it later, but I think it's fine for now. And then in the response, we already have the first line. We render it before, which gives us the version and statuses. And then we can intercalate it together with new lines. And I think we need to separate the headers. So first we're gonna have content type header, content length header, then we're gonna have a separation between this and the body, and then it's gonna be content or the body, and then the one at the end. So content type is a header. We'll render it with colon in between, which is named content type, and the value is text plain, which would be nice to extract and have it less stringy, but I think it's okay for now. And the content length is actually depends on the body. We need to calculate it. Response body is a maybe byte string. In theory, if there is no content, there shouldn't be content length and content type. So we can pattern match and check. But alternatively, if we got to the point and we pass the body with the one controlling it, we can just go to 0. Otherwise, we get the length, which is not the best, I think, but should be fine for now. And render header now takes a header and a value, and we can And we can concatenate them together with colon in between. I think the issue one is the first one is a byte string, the second one is a string, because we're using show, so we just need to pack it just to make sure it works. And the content should be just response body, but taken out of the maybe. We cannot do empty string, it's gonna be a bit awkward. So I think the easiest thing to do is, one thing to do is to have get maybes. If we pass a maybe, it's just gonna throw it out of the list, but then it means we have to wrap and rewrap everything, which is annoying. The other option is to pattern match on the response body right away, and then if the body is just a body, then we construct one type of the response, and if not, we construct different type of response. I mean, render it, but doesn't matter, it's the same thing. And then we don't need content maybe, and we just have a body. And in the second case, we're not gonna pass the body and not gonna pass the headers, which is a lot of duplication. We can try to move it out, but then it's also not perfect. If we are already manipulating and playing around with a list, the easiest thing to do is to model everything as a list. So if we say the content is a list, or even more than that, if the response body is there, we're gonna pass the headers, content type and content length as a list, concatenate it to the first line, and then close it with the last line. And the idea is that if content length is there, it's a list, so we just concatenate everything together, we're gonna have more elements. And if the content is empty list, so we just keep it and we don't do anything, like it has no effect. So it's first line, maybe content, or headers and the content, and then the last line. Just to make it symmetrical, we can wrap the first line as well. Okay, this should be more or less it. And it's once again time to move everything out because it's too much stuff. Everything that's HTTP response related is gonna be in the module called HTTP response. Making response with or without body, and then rendering the response and the response as well. We should not forget imports and then extensions. Okay, if we run it and send it a request, we get back okay for the echo, but we didn't expect okay. Maybe we move them around? I'm not sure. It shouldn't match this way, but shouldn't be more. Somehow the handler is not working. Let's print the response and see what did we make. We need to show and then pack it. Because we don't have a show instance, we need to add it. Just derive it show. So let's run it again. Send it a request and see nothing. There's something with a pass that I'm not seeing. It's either before or after that it doesn't work. So the interesting thing that I see and you don't see is that it doesn't matter. The whole point is that it was supposed to be a suffix and not prefix. And now we get the proper response. We see content type, content length, and the body. But it also says that there is some access found. It says the length is 3, but somehow we gave a bit more. And ABC is 3, and we don't need this one. Let's just... So I'm suspicious about this intercalate. Because we have 1 here, and then we're gonna wrap it around. And I think this one plus the other one is gonna give us 3. So maybe we just remove it. We're just gonna do it ad hoc. After the first line, we have a break. And we need a break after each header. So we can add it to render header. And then probably don't even need one. I think I was just thinking that we might need those two we saw in the beginning, but I think we needed those two because we didn't have the headers and we didn't have the content, so we were just having two empty lines. But we might need one in between, because we saw in the response it looked like an empty line between headers. So maybe that's the only ones that we need. One after the line, one after each header, and one between the headers and the content. And then we tie all of these together with concat. So concat doesn't work, is it? It works on the lists, and we have byte strings. Is there a BC concat? Yep. List of byte strings, and then gives us a byte string. Headers is just something I wanted to refactor. So now we can pattern match on the body and then get headers separately from the body. In the first case, both of them are going to be lists with some data, and in the second case, it's going to be two empty lists. Well, in theory, we could have done it once, but now I'm kind of skeptical that I know what I'm doing, so I'll just separate it so it's easier to refactor and update in the future when we get more knowledge or more data or more stuff to deliver. If we run it now and set it a get request, if we send echo Scooby, we get the length 6, and then no complaints about the over access. I think we can just submit it. Another success. The next stage is about parsing the headers. They're gonna send us something to user agent, and we have to include user agent header. They will include user agent header, and then we need to respond with 200 and put back what we got into the header. Which means we need to extend the HTTP request. Now it has only path, but we can add the headers, which is a list of byte string, but maybe it's better to have a map of byte strings from byte string to a byte string. For this, we're gonna have to add the containers library and import data map string as map, and we can use it. It doesn't work because it wants map.map, which is annoying, so we can import the map part directly and keep it just as map. We can start by declaring user agent header so we don't forget it, but I'm not sure we're gonna use it anytime soon. We have to think about how we're gonna extract those headers. We used the break substring before. I guess we have to do the same. And yeah, they have this tokenize function here, which drops the delimiters. And I wish there was function for this, but I think we just need to reuse or build something similar, because we want to break everything that we receive into lines, and we don't want these new lines breaks. What we get is that we get the first line, the status line, then we get some headers, then we get an empty, like a break, and then we get the body. And I think if we break it into list of things, we can get the first line, then get the headers, and then deal with the body later. So let's not worry about it for now. Let's just call the lines, extract the lines, and go from there. It's gonna take a byte string and return a list of byte strings. We're gonna use the good old Go pattern, where we start with an empty list, and then we're gonna go through all the line one by one and accumulate the result. So the Go function is gonna take accumulator, the lines. First we match. We break the substring on the line break. Then we get a tuple where the first part is everything before the line, like a line if there was one. And then the rest. At some point it's going to be empty, and I think this is where we stop. So if we got to the last line and it's empty, we just return accumulator. But we need to not forget this last line that we got before we got to the end. We'll have to skip or drop this line break, and we can just call a length to remember how to do it. I'm not sure if we need it in the first case, because it's kind of the last line. It shouldn't have anything, but let's drop it for now and just think about it later. Let's just implement it to make it easier. So we're gonna skip the rest that we need from the line, and then we're gonna return it. Or we can skip in another case. Because in this case, in the recursive case, the one that we're still going through and the rest is not empty, we're gonna call go again, pass the rest, and also accumulate. So we're kind of doing it twice. We don't need this and that. Well, let's go back. So if it's gonna be HTTP request, we're gonna pass it the first line and we're gonna pass it the header, and then it's gonna construct the HTTP request. If we take the lines first, we break the request lines, we break the raw lines using this request line function we were just trying to implement, and then we take the head for now out of the lines, which is also not good to use. We're gonna get the first line. It doesn't compile because the HTTP request has the headers now, and we actually don't care about it, so we can just skip it. Let's give it a quick spin. So send a request and then send a connection. The interesting thing is I get nothing. Like it just gets stuck. So we probably hang it. The probably recursion just never stops. Let's add an intermediate step where we get intermediate TMP, then pattern match on this, and just trace and show it, so we know what's happening. Like, how did we broke it into two parts, and see if we never reach it. I think we just never reach it. My suspicion, one of these drop skips is too much, and we just never reach the base case. Run it again. Curl it. Get stuck again. Yeah, I see. So yeah, the first one is always empty. The second one always the same. It makes sense. Because we skipped in the wrong place. We keep going on this line, on the initial line, and initial line is just empty, and then it doesn't matter, we keep dropping stuff and keep adding it to go, and we just keep going and going. Well, we had to drop it from the rest. So we got the line, we add it to accumulator, we drop skip the rest, this line break in the second case, and then we keep going. So it means if we drop it in the second case, we can pass it along, and at the end it's already dropped, and just return. So when we run it, we get first line, then the headers, and we slowly get one by one, but we get in reverse order, so we need to reverse it. Because we're accumulating lists, we get the first line, we add it to the list, then we prepend the headers, the other headers, and body, we get a reverse order, so we reverse and return. Time to clean up and do the rest. We don't need the TMP anymore. We can move request lines inside the parse request function, because we're not going to use it anywhere else, and simplify the signature. Because it's part of the parse request, we don't need to pass the raw anymore. We can just use it straight away and simplify it. And then we just have request lines. We don't need to call the function, we just have the request lines, and we just need to decide what we're going to do with it next. We do care a lot for now about the first line, so we can split the whole list into first line and then the rest. If we have empty for some reason, we return nothing, just somehow we just got nothing. And then we need to decide what are we gonna do. We have first line, which is we've used before. We know that we extract the path out of it, or whatever we're gonna extract in the future, and that we're gonna do something with the rest. We need to extract headers right now, but in the future we're gonna extract the body from the rest as well, so we can move what we had before up. Not to forget, makes sense to recall that this is gonna swallow path, and the other one's gonna swallow everything but headers. So extract headers functions takes a byte strings once again, and actually a list of byte strings, like all these lines we did, and then the return type should be a map, as we created from byte string to byte strip, and because it's quite long, we can just call it headers and use it once, but not a fan of type aliases. I think it's easier to just create a new type that we can reuse and have it more precise. But it's kind of annoying to have it also maybe type aliases. I don't know. Let's just put it there for now and then put it back. Let's just see if everything compiles. So what we want is we want to split or stop or break on the empty line. We take all the headers up until the point we get to the body. So we have a span function or partition, I think span function, which breaks a whole list into two parts. First one up until the point it matches something, and then the second part. And the first part is going to be, yeah, the first part is going to be everything up until the equals, like all the headers. And then the rest, which is probably body and something random. Null checks if the string by string is empty and not flips it, so we can split up until the empty one and afterwards. So we're gonna have headers and the body, or potentially the body and the rest. Yeah, not sure how it's gonna work. Probably not gonna work with empty headers and empty bodies or no bodies, but I think it's good enough for now. We can do a little fold with just extract headers for now, which I'm gonna call F, and then we start with an empty map. I'm gonna go through all the headers, through all the list of by string, and then we're gonna write this extra headers, which is just F, copy the signature, which is by string to headers and headers. By string is a line, and headers is accumulator, and headers is just a conflict. We can call it raw headers, and body we don't care about, and it's gonna be raw headers. Lines are raw lines. Each header is a line with header name, colon, space, and then header value. So what we can do again is the span or the split that we did before up until colon, or we can just drop the break substring again. Oh, interesting, there is a break, but it's opposite of span, so it's not what I was looking for, but I think it simplifies. Like knowing that breaks is opposite of span, we can refactor the other one, but here still use break substring because it's a bit different in this case. So if we break the substring, it's gonna be a name followed by almost a value because it's gonna have a colon again. So if we pass a line, we're gonna see that we have name and almost a value. In that case, it's just emptiness. So we just need to extract the actual value out of the value, and I think we can just drop the colon. And for the header, I would create a new type. This is just a wrapper over the by string. It's easier to have a new type in this case, so we don't have to mix up names and values, and also it's a limited amount of names, and we want to limit the lowercase, uppercase, like the case sensitivity. So I think it's easier to control the way to create headers and names, just in our way. And while we already create new types, I think the initial thing about headers, just have a new type, brings me back to have a new type. We can create a new type and then derive everything anyways. So this one needs a show as well. Now the empty fails because it's not a map anymore. We can derive monoid for the empty, which is gonna create new empty map, which wants generous new type deriving, which is extensions that we need to add for this case. And then monoid also wants a semigroup. So we add a semigroup. And then this one also wants an ort on header name. And we can add an ort, and this will probably want an equal. Yeah, and it wants an equals as well. So now instead of map, we just write empty. So now we need to create a custom way for creating header names by passing the by string and giving back header name. I think the easiest would be is to lowercase everything. So we don't have to compare uppercases, lowercases. Don't, like, if everything is lowercase all the time, it's just gonna be easier to compare. There's only two lower. There's no lower on BC. Yeah, by string maybe doesn't have it. Probably doesn't make sense. It's not a text. So we can just map and then lowercase each character. The result is a header name. and we just rewrap it as a header name. So now we have a name, a way to create the header name, a value. So let's just add it to accumulator. We can map insert header name, pass it a name, a value, and the last thing is accumulator, which is not gonna work because we have headers, not a map. We need to unwrap it and rewrap it there, but maybe it's easier to just create a function that add the header to headers, and in case we refactor or change stuff in the future, the interface still stays. The interface for the add header name is gonna be add header name header value, which is byte string for now, also not perfect. Headers, and then the headers add header name. We can unwrap headers right here, and then map insert what we just inserted, and then use map header there, wrap to headers here, and don't need to rewrap stuff because name is already wrapped. All configs is also just called accumulator. So now it should compile and be working. So instead of doing nothing, we want to extract headers. Because extract headers always successful, we get headers back, and we want adjust, we can wrap it in adjust. Maybe a trace, maybe another trace on headers, not gonna hurt while we're trying it out. Run the server. One thing is that we don't see nothing. Not just you, me as well. We need to force it. We can add the bang patterns and add a bang in front of the headers to force Haskell to actually evaluate it, because we didn't use it anywhere, we just ignore it. Haskell was also ignoring it and not printing anything. Now I see the headers and you don't, but if you trust me, I see that there is another issue. There is an extra space, and because we were dropping just one, there is a space in front of the value. Like you see this row. As you can see, each header has a space in front of the value, and we're ignoring this. Not the nicest, and I'm not sure it's required or a protocol part of it, but is there any errors? If there is any bugs with these wrong headers, we just tell people to look here. If this is working, the next thing we want is to get the header value by header name. We'll also need to pass headers. We can use map lookup to get a name out of the headers. We also need to return maybe instead. And now we can use user agent that we've been hiding for a while and make a user agent header name. Now we have a perfect opportunity to extract the headers, drop the bang patterns, trace show ID, and move everything to headers. Call it headers, move user agent up. Export user agent headers without actual constructors, because we don't want people to create new types by themselves. We only want them to use add header or get header values to manipulate those. We should also move the imports to the headers, everything that's related to map, and the extensions. And then we export everything here for usage. What I want to do before we wrap up, I want to change this default handler so we separate the maybe default part from the actual handlers that we're writing. So this part is going to take the byte string and return the response. So it's going to take the whole initial parsing. It's going to parse request, the row request, get a request. We're going to pattern match on it. If it succeeded, we pass it to the next handler, the one that already has the proper request without any babies, or otherwise it's going to be 400. And in this case, we don't have to worry about any and this is not needed. We have pure logic and matching. And we can call this handle request, or maybe just handle input. And then we have, and now it's a bit easier to extend our handler. Oh, it's similar to our root. We have user agent and headers, which this time we're going to use, and then we're going to pass it around to the user agent handler, this time with headers, not the path. The user agent handler takes headers of type headers and returns HTTP response. Headers is a conflicting name, so let's just call it headers. we have headers, user agents that we can check for. Using function headers get header value, which we need to import. User agent was also not imported. Let's just do it by hand because we want it qualified as headers. So then we pattern match on the agent because in theory it might be missing. Right? In practice it's mostly missing. In theory it should. So if we have an agent, we get if we have just agent, we return 200 with the body, and if we have nothing, we give them bad response. 400 bad request. It's a good response, which says it's a bad request. And then we can explain ourselves, saying that we expected some user agent. We need to turn agent into the body, but its body is already should be maybe, so we don't have to unwrap it and wrap it. We just pass the maybe along, and in the second case, we just wrap in just. All right. Hopefully, final try for this stage. So user agent gives back content length and then the body. So we can submit. While we wait, let's look at the next task. Concurrent connections. Okay, so we just need to handle multiple concurrent connections and respond to it. Okay, cool. The previous one is done. All successful. Let's go to the concurrent connections. Most of the logic is here. In this forever block, we receive connections and handle them, and then we close the socket. Only thing up to this point, from line 45 to 51, is something that can be done in concurrently. And if we check the docs for the module, we can see that they run in TCP server. They do something similar. They bracket opening and closing. I'm not sure we need to do it. We kind of do it already. And then on forever, they also, fork finally. I think it's pretty much what we need. We just fork and finally close this if something gets wrong. Is it gonna close everything for everybody? We fork one, we do something, and then if something goes wrong, we just close the whole connection. We just close everything. And they also use send all. The programming model socket, send by single thread, multiple thread concurrently, unexpected things will happen. Yeah, but we read it only once and then we handle it. There is one exception for multiple ones. Okay, this first I got encouraged by the beginning of it, and then the other thing was not very encouraging. So let's just split it and see if it works or not. The handle connection, we can split it separately. We just get a socket. And closing, closing should be done there. We don't want to close anything for anybody else unless something happens. So this is the single threaded. And then we add fork finally on top of it. And fork finally wants to close. And not just close, it wants to function based on the error. Yeah, based on either. So this should be it. Let's just run it. There's no way other than running. And it passed. Just get to the next stage. Yeah, I think it just forks and it's fine. I'll not overthink it. So the next task is getting a file. We need to return the contents of the file. The program is going to be executed with a flag ---- directory. Interesting. That's a new thing. And then get files, file name exists in the directory, we get 200, okay. File name exists in the directory 200, okay. Content type octet stream, otherwise 404. Absolute pass. Okay, this time I'm gonna be smarter. We're not gonna do stuff by hand. Let's just use a library for parsing CLI options. So first thing we need to do is handle directory, and then we're gonna do all of this, 200, 404, add a new handler, so just don't forget it and don't go back. There's a library called opparse, opparse applicative. Yeah, opparse applicative, which gives us quick start and just sample stuff, pretty much what we need. Okay, let's add the library. Okay, let's create a new module for the HTTP server. Move the run here. Instead of main, it's going to be HTTP server. most of the imports should stay the same. We pass in host and port here. Maybe we can move it to some sort of configuration. The run is gonna take, we can write it this way, that it takes a host and a port and then it gives it back, or we just bundle everything together in the config. The config record is gonna be, for now, the host BC string, the byte string, and then the port byte string. And then to run the server, we need to pass a config. It's a byte string, but get address wants host name, and the other one is strings. Okay, let's just make it a string. Now it's better. And the configuration is gonna go to main. Let's export the config file, the configuration record, and go back to main. So main has full of stuff that we don't need. We just need to import HTTP server. Up to this point is just configs, and then we run the server with configuration, host, and port, and everything else just can be dropped. Let's rename config for name collisions as a curse for this implementation, and then go back, and then it should be fine. After 2 hours of this, I'm starting to regret more of not using proper extensions. Okay, let's go back to our ops applicative. We need to re-import it, and we can readjust the quick start example. What we want is the sample, which is our args, and we only care about directory for now, which is just a string. And the parser is gonna be taking a string option with directory, and we don't care about anything else. So it's a string option. Metavar is going to be directory. The help text is directory. What is it? Absolute path for all the files. Absolute path to the directory with static files. And that's pretty much it. The samples is just our args. And then the args. Yeah, minus directory. We can also add short one from an example. And this is how we run it. The main thing here is the exec, and then the option which adds info and a helper, which might be useful for us as well. Not useful, but interesting, and just not for the assignment, but just for our souls, and in case we extend it later. So to get the args, we need to exec the parser, and then pass it down to the config. In our case, another sample, it's an args, and the program description is my HTTP server. And the whole ops give us not just, it gives us a parser info on top of the parser we had before. In the config, we don't need the whole args, maybe just directory. Let's extend the configuration, add a directory which is just a string, maybe file path. I think we can use file path. It's just a string type anyways, just to make it clear. And the file path here as well. Args is conflicting with a function name. So the actual input args, and then directory. Or we can pattern match right away. So we don't even have to deal with names and just say directory. But then once again, name conflict. And also with the future, if we extend it, not the best. Maybe let's just undo it. Just pass it like this for now. And then to verify that everything works, we can just print what kind of stuff we're running with. Args needs show, and this needs parentheses or moving stuff around. And if we try to run it, we can see how it's going. So you see, we are missing the directory because we made it, but it says some information on it. We're not missing, we made it required. We can say that the short one is D, which is not a string, it's a character. It's a character. And then we can say that the whole string option is optional by wrapping it in optional. This is a maybe because we say it's not a maybe, and then we make it a maybe and make it a maybe here. And now it says that maybe parser Is it parentheses issue? And then wait, parentheses, and now it should be better. If you run it again, we see that we're running it with directory nothing. And if we run it with -help, we see the available options, the absolute path, the description, and then the help text, which is nice. And then we can pass the directory, for example, test, and see that directory is testing. And see that testing directory has been passed. Now we have to implement the handler. We need the files, which is going to be similar to echo. Once again, regrets about doing this twice. Okay, let's just say files, and then the file handlers with another. Use files handler. Files handler takes the file path, strips the files prefix again, second time in a row, and then returns 200 okay with the content type, and then everything else. So if the file exists, we do one thing. We need to implement headers, and then we need to implement having the content of the body. In the other case, it's for try the with prefix. It starts with some prefix, and then we can say that it starts with some prefix and maybe pass it or extract it. View patterns. It's just ugly any way I look at it without actual parsing as a URI or as a file path. What if we try URI instead in the past? We don't have one. Is it network IO? Network URI? I'll just try network URI, build it, then it's not working. Yes, not working. URI, all caps. Okay. This is not working because extract path should be URI. Just is a parse URI. Parse URI takes a string, returns maybe URI. Guess it should be enough. HTTP path. Need to unpack it back to a string. So we parse URI and pass it around. So here now we don't have a strings anymore. So here we don't have byte string anymore. We can extract the request. It's gonna be path and then headers. And then we pattern match on the request path. In this case, there is a path segments function that drops the segments from the URI and gives us a list of strings. And I think if the first one is user agent, I don't need any of this. It's going to be user agent and then empty. No, in this case it's not empty. It's whatever else. Or maybe it's empty. I think they said empty. Root is just empty because we don't have anything. And then echo is the first one is echo. The rest is the rest of the path, which is more interesting. And we're gonna pass it along. This one is a copy paste. Files is similar to echo. The first is files, followed by the rest file passes. We don't need that. And pass it along. User agent needs request headers. And then in the last case, whatever's left is just not found. And we don't need to reinvent this thing. What we need to do is to match the list of strings to just a byte string. So we need to merge it back together. Can we just intercalate it back with slashes? Kind of rebuild the path? No, it's intercalate. Does it need to be whole wrapped again? Because this one works on the byte string and this one is list of strings, so we need to map each one. We need to map each and pack it. And we have to do it twice. So we can have some sort of repass function which does all of this. Take some past segments that we just broke a second ago, takes the segments we just broke a second ago, and then wraps them back. So we can repass echo and repass file path. Okay, so not the best, because we breaking the segments and then we're doing them again, but at the same time, it's really nicer to match on it. Just move the OK higher to make it structurally and adapt everything else because we now doing this stripping. We don't need to strip this part anymore. We can just pass it on. This one is maybe, so we just wrap it and adjust. Okay, nicer already. And we can start working with the files handler. Now it takes a file path and turns in fun now. We can use system directory to, there is a directory module, system directories, that we can create directories, remove directories, set current directory. Yeah. So we just change the working directories to the given path. We don't have to do it multiple times. We just do it on the entry point of the app. And then we need something for existing, rename path, make absolute. Does path exist? That's what is the given path points. Does file exist? Yeah, does file exist, operation system. And then we check the byte string. The byte string should have something for writing and reading directly to the files. Cool, yeah, just one function. If you go back to the code, this one doesn't compile because we want file path, and the file path is a string, while we have this works with if we drop the type signature, it works, but we need to just unpack it. This is not very cool. So first thing we need to do is to check for does file exist or not. It's not there, module missing. So we can exit directory module, rebuild it, and then does file exist can be imported now. It's an IO, so we need to change this to the IO HTTP response, which makes everything an IO. Go to old IO propagation, this an IO, this becomes pure. This one's pure, pure, pure. This one is pure. Just to wrap everything up. And this one also, this one is IO as well. This one is pure. And then this should be binded. Should use bind here. And then everything's looking good. Does file exist returns IO of boolean, which we can just bind to exist. Is there something like if m, if no, is it when? No, when takes a boolean. No, let's just use the if. Let's just bind and do it boring way. We need do pass a file path, and then if exists, then we return 200. Okay for now, with undefined body. And if it does not exist, we return 404, which is not found. It doesn't like it because we need a pure. In case of body, we have nothing, we don't need it. And I think we have make response no body. Don't mention it. I think, how do we go to the directory? Do we want to set the directory, the one that we saw before? Or do we want to pass it here? I think the easiest would be to get it from the configuration and just set it once here. So we set current directory to the config directory. The directory is a maybe, so if we don't pass it, we don't set it. In case of nothing, we do nothing. We do pure nothing and pure unit. And then if we have a directory, we set the directory. We set current directory to directory. So let's just say that we set the directory to source static files. Okay, let's improve our HTTP response module. One thing we can add is status code and status text. For example, we can say that OK is OK, HTTP OK is OK, not found is not found, and bad request is bad request. At least to reduce some copy-paste errors. Still not sure if the status code should be tied together or not. Like in theory, it's given, but maybe somebody wants to change it. So let's just deal with strings for now. Bad request becomes bad request, not found becomes not found. All the OK become OK, and not found becomes not found. Just need to import OK. One more bad request, which is actually good that now it's points out that it was 4, which is should have been 400. Okay, let's do the response body. It's better to create an entity in this case because we have different content types and they treat it differently at the end, like they give us different headers. Makes sense to differentiate them from the beginning. If we have plain text response body with some byte string or binary file, or binary file with some byte string, then we can pass them around. And if we have none, we have none. So we HTTP response now gonna have response body. We change nothing to none and re-export the response body. We'll change the rendering. Now none becomes none. And all these functions start to be more smarter. If we have plain text or binary file, we have different headers. We can turn the content type. We can extract this plain text part because it's plain text header. And then we can make another one for the octet string. Maybe you should consider moving these two headers while we're here. Again, this one is application octet stream. This one gets plain text and this one gets the stream. The length needs to be calculated based on the body, so we pass the body. The body's here, maybe a body. I think we don't need this maybe anymore. We know that either we get the body or we get the body. So we can change this to byte string and then drop this ugliness that we had for a while and just show the length. This one gets plain text, this one gets the stream, the length is still there, body is body. Let's just adapt the handler. Nothing, or we can just move it to response no body. Just becomes, the previous just become plain text. This one is not plain text, this is filer. What was body? Binary file. This one is binary file with some undefined for now. Agent is a just, oh now we have to rewrap it. Take an agent, we wrap it as plain text. Bad request is a plain text. And just need to do the rest. We can move pure in here because here we need to read the file. So if the file exists, the first thing we do is get the content with PC read, not this read file, and pass it to file path. Then we get a content and pass it along. The result should be pure. We check if the file exists. Let's see if we got the correct file path from the headers in the first place, from the request in the first place. Then we read the file and return to 100 with the content of it. Maybe let's check if it's let's check if exists is also fine and run it. Let's try it first with the current directory. And in the current directory, first let's check if everything is working actually. User agents. User agents was user agent, not agents. That's why we get 400, and now we get bad request. The other 400, the expected one. Which means if we call the root, we get 400, and it's not what we expected. Which means something with root is wrong. The parse URL, is it parsing URL is not working? Let's just, we didn't test it, let's show it. The before and after for the path. To run it again, send request, the root is / and then it says it's nothing. So instead of check the docs, in the docs there is this note that we might need to use parse relative reference or parse URL reference. Yeah, we need a relative one. Maybe that's the issue. I mean, probably that's the issue because I think the other behavior used to be the other way around. Now we get 200 and we get just /. Okay, just the wrong function. If we check the files with the test, we get false because test does not exist. If we check with something like our stack file, we get the stack file back. the application octet stream. The stream is there. So I think it should be fine. Let's just clean everything up. And a few traces right here. Or maybe let's just check if the directory is working. What if we run it with tmp in the just tmp is working. In the tmp we can put something at test and get back to testing. Okay, passing directory works as well. Now we can clean up. So let's try to submit another stage. Okay, so post file. I think at this stage we have to do a post instead, or on top, and save something to the directory. In the previous one and in this one we passed the flag directory, we already have it. Now we need to accept post files file name, which is the same path but different method, and then the body will contain the contents of the file. We have to take it and save it to the file name and should return to a 1, which I assume reading back should work as well. So we kind of have two directional thing. Okay, so let's go back to the handler. I think one thing we need to do is to extract not just the path, but maybe actual method this time, because now we just taking the path, unpacking, and yeah, I think we still don't need the version. Let's just keep swallowing the version. The path part stays the same. We just need to add a method. Let's do it undefined for now, and then the path stays the same. Let's call the method HTTP method for name conflicts. And rename everything to parse status line instead of just the URI. The result should be maybe URI, maybe something else. Because this one is going to be maybe, it's going to be maybe a tuple, I guess. But then it's not easy to put in HTTP request a tuple and then there's a header. So maybe we can, yeah, let's do the tuple. Like it's going to be easier in this part. This is going to be just some HTTP method. We don't have it for now. And let's just return method and a path. The HTTP method is not implemented. Let's just edit a dummy one, just a phantom that HTTP method. And then because both of them are maybe, and it kind of doesn't make sense to have one without another one. Like if we fail to parse one, we definitely fail to parse another one. So we can just do everything in the do comprehension. We try to parse first one, try to parse the path, and then return both. If parsing one fails, parsing in total fails. The path, once again, common name. We can rename to parsed path, and then the same for HTTP method, but we'll do later. We just need to pass it as a method, and yeah, just extract the HTTP method or parse HTTP method. It's gonna be something similar. We take a byte string, we return maybe HTTP method. We pass a byte string and then return maybe HTTP method and URI or nothing. In this case, once, as I mentioned before, HTTP request is not happy about taking a tuple, so we can do a helpful little method that's just gonna repack it for us. We can make it other ways, but I think it doesn't worth it because in a couple of hours, in a couple of minutes, we're gonna add the body as well. So let's just take a tuple of 2 of those. This one is still lifted in just for no reason, just for now. But we just pass it the same way, and then the result is gonna be HTTP request. Because later we're gonna take the body as well. It's kind of awkward. Maybe I'm not gonna take the body at all. Let's see. And we just need to rewrap the tuple to make everything nice and curl it as Haskell wants it. And also it's missing a method, so we need to add a method, which is just an HTTP method, and at some point we're gonna add a body. I think it doesn't matter. We can start with the method first, then the path, and then headers, and then the body. It doesn't really matter. So then we derive and show, because we want to show it already in the HTTP request, add get and post. Everything else is usual to do, implement later. I don't think we need any other ones, even though it's easy to list them. It's not easy to stop coding and Google stuff around to remember. So let's keep it for now and replace the normal constructor with smart or maybe dumb constructor, whatever you want to call it. And then rename everything to parsed for consistency, but also to fight the namings. Let's just actually implement this parse HTTP method. Get is a get, and it's a pure because of maybe, and then post is a post, and everything else is not implemented for now. Let's just throw it away. And we can just move it to its own place, to the HTTP method, mention that it needs to be extended, move the imports. I think it's more nicer to call it just from byte string and then maybe to byte string just for symmetry and make it used as qualified after that. There's no maybe here because it's if we have an ADT already, we can definitely show it. So it's just going to be get, and post, and everything else. So it's hopefully going to be implemented by somebody else. If we try to compile, we see that the syntax is a bit off and the naming is a bit off, copy-paste mistakes, and overload the strings is missing. So we just carry it around here as well. Now everything should build more or less up to the point where we actually use it because we added more stuff to HTTP request. But this can be removed and simplified, and we can import the HTTP method instead. And for parsing, we want it qualified. Okay, I guess the parse status line is okay. I think we should have done it before, but now it's working and now it looks better. The only thing left is actually the body. We just need to fix what we pass here, whatever request method we pass it through. And then we use it. We can take a request method and use it in the pattern matching as well, even though most of it is still get, not very many changes. We just need to change the handler. We can have one handler, which is files handler get, or get files handler, and similar one, just post file handler. Might be a bit confusing naming wise if somebody thinks that it's a getter for file handler, but I think it's fine for now. We don't need any of this. We just need a file path, and eventually we'll need a body, but we don't have a body yet, so I think that's the next logical thing is to add a body. And to make sure that this part is still working, let's just try it before we go to the body. So if we run it again, we don't care what directory, it's working for now fine. Then we can see that we have a get and a post and a file path as it was before. So it's fine. I think we can move on to the body. So if we add the body to HTTP request, it's probably just a byte string for now. We don't have to worry about other formats or other things. We know that it's going to work. What we have to worry is actually implementing this, because what we have now is we have extract headers, which returns headers and byte string. I mean, we kind of swallow it. But the problem here is that we can return and we can try to say like, oh, we did this part, and then we can try the other part. We can even make it explicit and say that it's parse headers and emptiness and body, but it's not very nice because it's not a byte string anymore. It's going to be each line of it. So we have to either combine together or just change the whole request lines. Like request lines worked before because we cared about lines, but now that we have about the body, I think we need to reconsider what we have. We should split it. We should do it in parts. Like we do the first line first, then we take all the headers, and then we do the rest. And in current way, we just split everything, treating everything the same. So I think we should just adapt what we have. In other words, rewrite what we had before, because it's okay. It's not that much to write. We just need to kind of pretend like we're parsing. Should have used the parsing library before, but now we're here. We can do it. It's just one by one. Let's move this part. So one thing is that we keep reusing is splitting things. It would be nicer if we have a function that gives us a byte string, swallows this rn or line break, and gives us the rest. So we can take the first line, do something with it, what we want, and then we can do whatever we want with the rest. So which is just combination of what we had before. We had a break string, and then the drop that skips the length of the line break, so we don't care. We can extract it and reuse it. Probably can count it by hand, but I think it's fine to keep it. Haskell can handle. So this should give us what we need. So now we can treat it as a parser. You take one line and you have the rest, and we can go bit by bit and treat a different chunk as we need it. So we can start with the line, with the first line. Let's just rewrite the whole parse request. We can. So after we take the take line from the first row input, we have the first line, which is the actual first source line or status line, and we have the rest. And then we're gonna parse it with the parse status line. And I think because we're gonna have a bunch of maybes, and if parsing something like status line is gonna fail or some other thing is gonna go wrong, I think we can just fail, so we can have a do comprehension or like do block. And parse status line gives us the parse method, which we implemented, and parse status, which we just used. The only thing left is to implement the rest. So we have parse method, parse status, and I think we need headers and the body. I don't know why I was calling it parse status is parse pass, parse headers and parse body. What it doesn't like, it doesn't like that I've been copy pasting stuff again. It's not HTTP method, it's HTTP request. And now the two actual missing things is two actual missing things. We have parse headers, but now we have to treat it different. Now we don't have lines anymore as we did before. Now we have the rest, and the rest is byte string, which byte string has all the headers separated still by line breaks, and then the body. So from these headers, we can get the headers and the rest. And this time it's gonna be easier to treat it because it's gonna be the whole body. It's just gonna be body, pretty much. Like if we extract the headers, what's left is the body. So we don't need anything that we had before, and we don't need this hack around anymore. After we extract the headers, let's just complete the whole function, the whole skeleton. We're gonna have parse body, and maybe the rest. I think there should be nothing else, especially if we get the content lengths, right? Like if they give us the lengths and we get it, the whole byte string is there. So let's maybe parse the headers and think about the content lengths, or maybe we just extract it right away. And then we say that, okay, you ask for content lengths and you didn't have the body, it's your fault. Or maybe, yeah, let's just keep content lengths because it's also content type would be nice to parse, but it doesn't say to do this in the task, so we're not gonna do it. Maybe later. So let's start with content lengths. And if somebody passed content lengths, then we're gonna try to extract the body, and if not, we're just not gonna do it. And in this case, we might ignore the rest. So the result is gonna be just the parse body without the leftover byte strings. Okay, let's implement it. The current extract headers is old and deprecated, so let's just keep it in case we forget. And we just need to re-implement request lines into the extract headers new. And once again, we take a byte string with everything and maybe return headers. Like if parsing failing, like maybe the headers fails and we get the rest anyways. Well, let's say headers is a map of headers, and this is not gonna compose nicely. But maybe we see how it goes. I think it's one of the things that's like you can think it through, or you can just implement it and see where the rough edges are. Extract headers gonna do the whole traversing, but now instead of array, we can collect everything in the map of headers. And then when we stop, we stop. We don't need to reverse anymore. So what we were doing before is we were folding with an empty map, breaking the lines, and then extracting header one by one. And I think this time we can start with something similar, but instead of empty array, we can just start with an empty map, and then we accumulate all the headers in there. So on each line, we now need to take a line. We don't do the break string anymore. We take a line, we try to see it, and then we're not gonna do what we've done before. The best case in this case is not, it's a bit different because we need to extract the header anyways and then keep going. And it's not accumulator. It's, yeah, when do we stop? I think we stopped up the way around. Like we stop when we don't have any more headers. Like it means we got to the empty line. So we had all the headers, we got to the point where there's no more headers, and then we return. So it's opposite way around. I think we can just flip this one into there and this one to there and just kind of roll it back. So base case is we stop, and then we stop going stuff, and then the other case we keep going. We keep accumulating headers until we stop. We only extract headers in the other case. In this case, if we got all the headers, it means we're done. We can return all the headers back, and the rest is going to be probably the body or whatever the rest we need to parse. So we just return the accumulator. And yeah, it's just an empty map. We don't need any maybes. And in other case, we keep extracting the headers, and each header, it's what we had before. We already have this function. We pass it a line, we pass it the previous headers, and it's going to return us a new modified headers, and we keep going till the rest. And I think that should be it. This one thing just replaces both of the functions we had before. So now about the content lengths. We know that we have headers, and it might have content lengths inside, it might not. But let's just figure out the types. Imagine there is no content lengths, it's just a nothing. How would we extract the body? We nothing. I think it's probably integer, right? We can try byte string. No, parse it here. Let's just pass an integer. Like let's parse it there and pass here just an integer. So it's gonna be row lines. And then maybe a body depending on how much length we have. I think we can throw an exception or just throw away the rest, or ignore the rest. Yeah, let's just ignore the access and then just doesn't throw anything, because we're gonna take some lengths, and the take function, if the length is not enough, it's just gonna take whatever. Like if you pass it ABC and you say take 4, it's just gonna take ABC, doesn't care. Just gonna, and if we want too much, then we don't want to. Like, probably it's the right thing to do. It's gonna be to complain, right? Like we had it at the beginning of this whole implementation. You don't pass enough or you pass too much, the server complains. But in our case, probably we expect good actors, and if they give us the right lengths or not the right lengths, we just breed whatever. We try our best. So I'll just remove maybe. Doesn't worth it. Maybe in the future we can make it better. Okay, let's implement the get content lengths. We get some headers, just and return a value, maybe an integer. So let's just mock it again. We pass get content lengths, we parse the parsed headers, and then it's not working because it's not even a tuple anymore. It's just a parsed body here, and then we don't want to short circuit. Like its body is maybe, it's a maybe. Yeah, we don't want to fail. And this is always returning some length, so the bind is not working. We just need a map at nothing. No content length stays nothing, and then the just is going to be mapped to just, and the parse body becomes maybe byte string, and it doesn't compile because the type was expected to be there. It just should be maybe. So now we can finally implement the rest. I still feel guilty. Maybe let's add a to-do and say that we'll handle the content type and the length properly at some future, but at least our children gonna know that we tried. I think we already used content lengths before, so we can just stop spreading copy paste around. Yeah, let's just move everything to the headers. We can start with smaller part. Extract the header names separately for content type and content lengths. And then those are kind of already rendered headers. We can maybe move them back, or kind of rendering related, but at the same time, I don't know, it's kind of the edge. Let's just use this one here for now. We have a get header value function and then content length header, which returns byte string, and we need an integer. We can take that maybe and parse it. Is there anything for byte string? We need something from byte string to maybe integer. I'm not sure. Yeah, I don't. We probably just need to unpack it. We can unpack it to a string and then read it as an integer. I think it should be fine. Once again, existing bindings. Kind of I know energy from this. And this one wasn't supposed to be here because it's not qualified. Good old unqualified qualified. Let's just import it qualified again. I'm kind of worried that this read is not gonna work, and then we'll never know because it throws. But let's just try it, I guess. I think the easiest is just to show and see if it's gonna be there. And similar for the parts body, like if the length is okay, maybe just not even the whole body, let's just see the whole request. And headers as well, in case even before length fails, right? And maybe let's just use what we had here. Content length and then content type. I don't like the name conflicts. I don't know, just copy paste. Copy paste error, back to headers. Okay, so there's actual error here. Yes, because those are header names and we want byte strings. So the rendering of this becomes a problem here now. Well, strings are not good anyways here for some reason. So let's just use byte strings, and then this one should be this one, and this is a string. We just repack it. Yeah, but still headers. Maybe, yeah, header is and header name. So it's new type. We need to unpack it. But then it kind of starts leaking around what I was trying to avoid before. We can pass a header name and we can deconstruct it, but I think we cannot because we don't export this, which I guess we should now. Yes. It's not gonna fix it because it's not exported. We can export it, but then we have to move everything there, and yeah, it's not the best. Or we can create a new function here. Content length is already here. Let's just move it, I guess. I think it's kind of calls for it, having the rendering of header names and the whole headers here as well. Like in the future, we can move the parsing of the header and rendering of the whole header in one place. So I think it makes sense. It's not that bad. Like we can make it work here, but yeah, let's just move it. Just give them more appropriate names before moving. Prefix it to separate header names from headers without splitting the module or any documentation. I think it's the way to go. So now we can export only the constructors, and a bit awkward, but we don't have to export the rendering. And we don't have to export the internals. Now let's try again. Okay, now it's an actual error because we didn't implement the rest. When it's more than 3, here it's kind of ugly. I will just change it to request. And then we can still pattern match only on method and the path. We don't need to pattern match on the rest. And then file wants the body, which was maybe byte string. Now we can pattern match on the body if the body was actual there as we expected. We do what we needed to do, and if it was not there, we do the rest, I guess. I think we just return 400. Yeah, like we wanted a body. In the first case, should be 201 and created. And because we don't have created, we can add the created. Still annoying. Maybe we should add the status codes as well. Getting at the annoyance level, but I think it's fine for now. Let's just keep it 201 and create it. And then we'll need a pure. And second pure here as well. Creating needs to be imported. I think it should be as easy as just write file as we had before. And then if it's successful or it's just whatever, just chain it to the, it's not imported. How do I? Sometimes probably need to add stuff by hand. I think it's in the data functor, not function. Yeah, so it's gonna do first thing, write to a file, and then it's gonna return to a 1. If the file writing is not gonna succeed, it's not gonna return to a 1. I think it's just gonna interrupt the connection, just die, which I guess is fine in this case. What do you expect from the server? Just give it a try. Empty connection. No links, no replies, as I said. Well, test testing, and there are headers, but there is nothing else. Well, as I said, some servers just don't give you much. There's something wrong with... Yeah, there's no file or anything. Something is not there. So if we saw one tracing from this one and we didn't saw the rest, then probably the length failed and what I was expecting was a read. And yeah, one thing is I'm suspecting that we are reading maybe integer, not in the way that we want it. Like we're reading it expecting that the text is going to say just 3 because of the type maybe, and we were not actually reading integer as optional. So yeah, we don't have to test when we have types, right? Yeah, now it's just 7 testing 7 content lengths, and we read it, and I think the file should be there. Yeah, new txt. And if we get it, yeah, you cannot see it on the screen. Let me just open it. Yeah, testing. It's here. Yeah, the only way to verify is now if we read it back so that again, then we get the same 7, and then the same testing. Yeah, it's kind of full circle. So I guess that's that. Server is ready. Do we have any to-dos? No, extend. Would be nice. It would be nice. I think, yeah, that's it. Let's just submit it. Yeah, obviously not a real HTTP server. I'll just move it here. Tons to improve. The header names, brand them. Not all the methods are implemented. Not the whole versions. Responses could have been better. I'm still not sure should be passed status code and status text separately or not. The whole handler is kind of awkward to separate it by lines, but it's working. Yeah, we passed the HTTP server is there, and all passed. Looks good. Yeah, I guess the next thing is refactoring and fixing things. Yeah, obviously not done, but feels pretty good. And if you want to feel pretty good about yourself as well, or learn some Haskell, the CodeCrafters affiliate link is in the description. Just give it a try. It doesn't hurt, especially if you're trying to learn something new. It's a pretty good way to learn stuff. You can try different languages. Haskell's not your thing, but I would obviously recommend trying Haskell. There are different tracks. You can try same thing as I did. You can also do the Redis. You can do some other Docker, whatever stuff. Each month they have different challenges for free. Just Redis is for free and HTTP server is also free. You don't want to try the whole service as well, and you don't need a fun UI to drive you around. You can also learn how some other things work by just going to the repository where they have build your own X list. They have some Haskell stuff, as I can see, some bots and cryptocurrencies as well, and some Scala as well. So if you don't want to commit to this or don't need a breakdown, just pretty good.